The authors introduce Big Bench, a unified benchmark for social bias in text-to-image generative models based on multimodal large language models, LLMs. This rapid development of text-to-image models has raised concerns about biases in human image generation against demographic groups, which existing methods fail to address. These methods are designed for specific models with fixed prompts, unable to accommodate the rapid updating of text-to-image models and variable prompts in practical scenes. Furthermore, they neglect the possibility of hallucinations, leading to deviations between expected and actual results. To address this issue, the authors propose VersusDebias, a novel and universal debiasing framework for biases in text-to-image models. VersusDebias consists of a generative adversarial mechanism, GAM, and a debiasing generation mechanism using a small language model, SLM. The self-adaptive GAM generates specialized attribute arrays for each prompt, diminishing the influence of hallucinations from text-to-image models. The SLM uses prompt engineering to generate debiased prompts for the text-to-image model, providing zero-shot debiasing ability and custom optimization for different models. Extensive experiments demonstrate VersusDebias's capability to rectify biases on arbitrary models across multiple protected attributes simultaneously, including gender, race, and age. VersusDebias outperforms existing methods in both zero-shot and few-shot situations, illustrating its extraordinary utility. The author's work is openly accessible to the research community to ensure reproducibility. Text-to-image models, as a crucial part of artificial intelligence-generated content, AIGC, technology, are evolving rapidly due to low barriers to entry and open-source initiatives. However, similar to other generative models, the growing adoption has raised concerns about fairness and biases in generated images, especially in images depicting humans. Existing methods face two major limitations. They are only applicable to certain text-to-image models and unable to zero-shot debias. The authors highlight that the widely adopted approach of distillation and community participation has led to rapid evolution of text-to-image models, making existing debiasing methods less applicable. Moreover, most methods consider only specific debiasing metrics and are unable to zero-shot debias. The VersusDebias framework proposes a solution to demographic bias in T2I models by introducing a generative adversarial mechanism, GAM, and a debiasing generation mechanism, DGM. The GAM generates debiased attribute arrays, which are then utilized by the DGM, a fine-tuned small language model, to identify and modify biased attributes in prompts. This framework is designed to be universal, adaptable to new models through inference, and compatible with thousands of models via interfaces. Evaluations demonstrate its effectiveness in reducing biases and outperforming existing methods. The framework's core contributions include a novel debiasing framework, integration of advanced technologies, and its ability to perform zero-shot debiasing with transferable interfaces. The authors highlight the rapid evolution of multimodal language models and small language models, which have improved the accuracy of traditional alignment models. This advancement provides essential support for the implementation of the discriminator in their proposed framework, VersusDebias. The development of Edge AI has led to a focus on SLMs, which retain most of the original performance of large language models while significantly reducing computational resource consumption. The authors then introduce the top-level pipeline of VersusDebias, which consists of a generative adversarial model, a debiasing generative model, and a corresponding dataset. The pipeline debiases a model by first using prompts without protected attributes to drive the generator to generate images, which are then conveyed into the discriminator. The discriminator employs a MLLM to perform zero-shot semantic alignment on these images, extracting information on the gender, race, and age of the depicted persons. The alignment results are statistically averaged to determine the generative demographic proportions of three protected attributes for each main prompt, the occupation. The discriminator compares the proportions of each gender, race, and age group to the ground truth and modifies the prompts by adding the underrepresented protected attributes, ensuring that the generator produces more images featuring these ignored social groups in the next iteration. The discriminator evaluates the generation results for each main prompt at each epoch, calculating the cosine similarity between the generative proportions and the ground truth to quantify the conformity between them. The protected attribute array with the highest cosine similarity for each main prompt across different epochs is then combined into a single dictionary, referred to as the best results, and conveyed to the DGM. The executor uses the fine-tuned SLM to accurately extract the potentially bias-inducing main prompt from the user prompt. It then selects an appropriate protected attribute based on the best results and adds it to the original prompt. Finally, the generator of the DGM uses the processed prompt to generate debiased images. The authors also highlight the flexibility of their framework, which can use any model in its generator, including diffusion-based models and transformer-based models. The VersusDebias system is designed to debiase text-to-image models by adjusting their input prompts to better reflect real-world demographics. It utilizes Comfy UI to connect with T2I models, ensuring a fully automated debiasing process and optimal compatibility. The discriminator in VersusDebias consists of three components: the aligner, array editor, and evaluator. The aligner extracts information about individuals in images and computes the average of the extraction results for all prompts of the same main prompt. The array editor compares generative proportions to the ground truth and adds underrepresented protected attributes to the prompt. The evaluator provides a comprehensive metric for evaluating the overlap between generated results and the ground truth when selecting the best performing debiased attribute arrays. The authors introduce a groundbreaking approach to debiasing text-to-image models by leveraging attribute arrays and a specialized model, VersusDebias. This model utilizes a small language model, SLM, to identify and correct potential biases in prompts. The architecture of VersusDebias comprises an evaluator and an executor, with the SLM fine-tuned to perform specific tasks in sequence. The fine-tuning process involves using a specialized dataset, DSLM, consisting of 500 dialog sets with 3 rounds of queries and expected responses. This dataset enhances the model's capability to execute tasks such as identifying potentially biased elements, determining if prompts include protected attributes, and identifying synonyms for occupations. Comparative experiments are conducted in the selection of SLMs, the performance of VersusDebias in debiasing various T2I models for both few-shot and zero-shot scenarios, and an investigation into the impact of attribute array length L. The authors compare VersusDebias with several baselines and discuss its potential applications in mitigating bias in AI systems. The authors evaluate the performance of 5 models, including Qwen 21.5b, Qwen 27b, Llama 27b, Mini CPM2b, and Gemma 2b, on a testset, comparing their responses to human evaluations. Qwen 21.5b achieves the highest accuracy and speed. The authors fine-tune Qwen 21.5b and Llama 27b, which approach the performance of ChatGPT 4o, validating the dataset design. They then investigate the debiasing performance of their method, VersusDebias, in few-shot and zero-shot scenarios. For few-shot scenarios, they generate 5 prompts for each of the 103 professions in the dataset and calculate the cosine similarity between the generated images and the ground truth. The results demonstrate VersusDebias's capability to effectively debiase models of various principles, especially in race and age. In zero-shot scenarios, the authors design an evaluation based on Big Bench, generating 8 images for each prompt and calculating the cosine similarity. The results show that VersusDebias achieves outstanding performance in zero-shot scenarios as well. The authors also investigate the impact of array length L on the debiasing performance, conducting experiments with L set to 5, 20, 50, and 100. The results show that a larger attribute array can result in smoother variations in generative demographic proportions, thus improving accuracy. The VersusDebias framework is a universal debiasing solution for text-to-image models, leveraging prompt engineering for precise and efficient debiasing. It introduces a generalized attribute model, GAM, and a sentence-level model, SLM, to generate and edit prompts, addressing model hallucinations and side effects. The approach significantly improves practicality and is shown to outperform baselines like SDV1, Fair Diffusion, and Precise Debias in terms of overall performance and attribute balance. The authors also discuss limitations and future work, including improving model alignment, handling extreme hallucinations, and addressing explicit bias. This research aims to promote fairer AI-generated content by contributing to the development of debiasing methods for T2I models. The research paper discusses the development of a novel algorithm for optimizing complex systems. It introduces a new methodology that combines machine learning techniques with traditional optimization methods to achieve better performance. The algorithm is designed to adapt to changing conditions and learn from past experiences, making it particularly useful for dynamic systems. The authors highlight the potential applications in fields such as logistics and finance, where efficient optimization can significantly impact decision-making processes. The paper also touches on the limitations of current optimization methods and the need for more adaptive and flexible solutions. This research paper proposes a novel framework for optimization of deep neural networks, focusing on the crucial aspect of gradient compression. The authors identify the primary challenges in existing compression methods, including high computational complexity and significant accuracy loss. To address these limitations, the authors introduce a new compression algorithm, dubbed sparse-thin compress (STC), which leverages the sparsity of gradients to reduce the communication overhead. The STC algorithm consists of two stages: sparse gradient calculation using a novel thresholding method, followed by compression using a learned compression matrix. The authors theoretically analyze the convergence of STC and provide a bound on the compression error. Theoretical results demonstrate that STC achieves a better trade-off between compression ratio and accuracy compared to existing methods. Experimental results on various deep learning models and datasets confirm the superiority of STC, with significant reductions in communication overhead and negligible accuracy loss. Notably, STC outperforms state-of-the-art compression methods by up to 3.5 times in terms of compression ratio while maintaining comparable accuracy. The paper also discusses the limitations of STC, including its dependence on the choice of thresholding method and compression matrix. Future work directions include exploring alternative thresholding methods and extending STC to other machine learning models. Overall, this research contributes to the development of efficient gradient compression methods, enabling faster and more accurate distributed deep learning.